recording this. So if this is recording, then we can start, I guess. This is going to be a very simple explanation about middleware. We're not really trying to cover everything about Unity, simply something that is a good principle to remember about why we're doing these projects and also why we're using this environment. Reinventing the wheel. A lot of game design over the years has been mostly about solving the similar type of problems, such as if you're doing a platformer, you're trying to collide with the same type of elements. You're trying to solve the same type of physics. You have friction, you have collision, you have gravity, you have forces that apply to an object, and thus having to do it over and over again for a company becomes a little bit wasteful. And to say wasteful and a little bit is undermining the real problem, which is every single game that you've ever made is going to be based off of the same types of events that the system allows you to detect and the functions that you create to resolve those events. So input is a general type of system that exists, detecting the keyboard, detecting the mouse, detecting a joystick, or so on and so forth. What happens when you do the input, now that becomes a very specific thing to your game. Almost like saying that if you were to play Super Mario Brothers and you pressed up and that's what makes Mario jump versus pressing A to make Mario jump, right? For the most part, when you press up in Mario, you only use it for going up the vines, at least in the original game, or any type of staircase. But up is a dead input. You can very easily do this, and some games actually have that function enabled. So input is one thing that the system provides for you. The function and what you do is what you have to customly create. Middleware is that type of solution. Close this out. Middleware has been around for a long, long time. I would say that the first popular version of middleware that was distributed was Pinball Construction Set. I think it was called Pinball Construction Set. It was a game in which you made pinball tables by placing different elements of pinball tables together, and you could make your own pinball game. So the game became about making games. You had other editors that you could do. You had Quake editors that you could make little levels and play Quake within it. You had renderware. The Quake engine eventually became available. You had the Unreal Engine a long time ago also. You have Game Maker, and now we're using Unity. The coolest thing about Unity, and in brief, that you can read what it says there, is that it really lets the developer, as much as I've been able to tell, custom create or custom arrange their project based on whatever constraints and limitations that you have. So one of the constraints that you may have is that you have different screen sizes that you have to account for. Right now, that's a big, big deal. If you're making a game for mobile, the limitation that you have is that to have it versatile enough that you can distribute it everywhere, you're going to have to play to the least common denominator. You can't just say, well, I'm going to have a 4,000 by 4,000 pixel screen. If let's say that you have a monitor or a tablet that has that amount of pixels, that's not necessarily the same constraint that another phone has, right? And you may want your game to be that generic. That's a word that I don't want to use it in the pejorative sense, but generic as in ubiquitous. So you go for the smaller screen size. That's why a lot of developers, even if Nexus or Samsung has a big phone with big screen real estate, they still develop for iPhone because iPhone is so popular, and they have one of the smallest form factors still. So those very big popular games such as King Games or what was the other one? Angry Birds. Any of those, they technically still run on the old iPhones that were the smaller form factor. You still have to account for that. Middleware would be one of those places in which you can explore those constraints and limitations in a rather easy way. Also, lets you customize your list of components that you have. Some of you have asked about 2D versus 3D games. A lot of people still make games in 3D and they cap it to 2D. But 2D also has some benefits in how you don't have to account for other aspects of 3D. For instance, rotations are limited to whatever's on the screen. Additionally, collisions are only limited to not volumes, but areas. That's a good simplification to have. Ultimately, that simplification depends on your project and how you want to customize that environment. So, the editor in Unity, as you've seen me use already, is broken up in these major components. The hierarchy, which is where you see how elements are placed on a scene or what a scene is composed of. The project, which is what your project allows any scene to be made up of. Anything that isn't in the project, Unity doesn't know about. So, and that's your workspace. That's where you drag in, drop whatever assets you're needing from elsewhere. The scene, which is where you can play while it's running. That's a very cool thing that Unity, I think they owned it the moment that it came out. They have a play button, pause, play, or step, right? Those things are very useful for when you're testing your environment. Typically, when you're coding, you want to have a good debug methodology or a good debugger. Debug works specifically in code where you can go line by line and check to see the values of each one of those lines or any one of those variables, or how memory is, or variables are placed in memory. But since we're playing on a visual environment as well, switching between line and editor for debugging one little variable doesn't make for the best flow. So Unity, what they've done is they've added that console. If you see at the bottom right there, the console is where you debug. And I know that you were talking about that very recently. So this is where they've solved for them how information flows and what the system is doing and what the user or designer is expecting. The game window is what's going to be shown on the screen. And that's obviously very useful. That's where you're going to be testing everything. And as a matter of fact, you'll notice that if you lose focus from that game window, none of your inputs will work. It'll be as if the game is still running, but not able to be interacted with. Lastly, the inspector. The inspector is that space where you can see all the variables and how they're occupied in memory. And they're attached to any one of the objects that exist on the world. So getting to know the hotkeys that make you or allow you to switch from one thing to the other is a very efficient thing for your workflow. And I highly recommend that you get used to those hotkeys in the editor, and also when you switch over to the code, that you know how to navigate the entirety of the code, up and down, left and right, from word to word, highlighting or selecting, copying, cut, copy, paste, all those hotkeys from your keyboard without using the mouse. That is, if I could give you any pro tip, That is the best one I can say. Memorize the hotkeys on any coding environment. It'll save you time. And one of the things that you want on a good workflow is to not regret the time that you've spent using either side, the code or the editor. And I know you were mentioning earlier that code, it's a little bit, the hassle, and you don't like to necessarily. I have a suspicion that a lot of the issues and friction that people have with code is that they're not acquainted with the keyword foo, not knowing how to be acrobatic with it. I am awesome at it. So I hope that you get to that level of comfort as I feel with it. Mono develop, and this is where I talk about that those hotkeys. I'll give you one and move on to the next slide. But if you highlight a line and you command slash, or I think control slash on Windows, I don't know which one it is on Windows. It may be different. At least I'm talking on mono develop. In Windows, you have Visual Studio, and Visual Studio is amazing in terms of hotkeys and all that. So you're going to have to discover that. But commenting in and out a line of code is one of the best things that you can do to memorize that hotkey. And also saving. You can. The tip here is to comment it, save it, switch to the editor, run it, and that can happen within 5 seconds to have a good testing environment of your script. The inspector, those are the basic elements that show up on any object. I tell you this, and I know that you've already seen this, but I really want you to be acquainted with these elements in there, because those elements are used directly with the event engine Salud that we're using in this class. Knowing how the transform affects your object is the same problem that we were showing you with squashing and skewing when you have a bad child-parent relationship. The cube and the mesh filter that you have is crucial. Obviously, that renders your object. You can turn that off, or you can have objects that don't have this. For instance, a parent object that is a compound collider doesn't need to have a mesh renderer, so that's a game component that you can skip. However, knowing that an object does not having a renderer and calling an event engine piece or line of a script that uses the renderer will give you an error. So knowing how those components are added to any game object is crucial. The box collider in this case is what comes default with a cube, which is what I've given you here. You don't have to use a box collider if your geometry is weirder. You can use a mesh collider. That is computationally more expensive though, so keep in mind how many colliders you have or how complex your scene is. A good suggestion on this is to gray box things, and if your object, let's say that you're doing a couch or a chair, you're never going to collide with a chair with between inside the legs or anything that requires that type of manipulation under the seat or behind or within the seat. Then just keep a cube and that's fine. That'll be very useful. A little tip on that is if you have a character and you want the first layer of collision to be simple for going up a little staircase or little ledge or something like that, make it a capsule, because the bottom part of the capsule is round, and that allows you to, when you're going against an object, that little round edge still allows you to climb that step. Whereas if it's flush like a cube, it'll collide and it'll never let you go through. It'll be like a snag. So See, knowing how the colliders work, knowing what these elements represent is mandatory for having a good comprehension of how these elements combine. That's ultimately what you're going to be doing. You're going to combine different elements, numerical spaces, temporal spaces, visual spaces, auditory spaces, interactive spaces, story spaces. That's what a designer does. You have to, unfortunately, be a master of all trades, a jack of none. That's how it works. The tag system, the names, the proper naming and tags that we have there. Earlier, we had an issue with not having the tags or knowing that a tag wasn't set up. Why is a tag important? Well, because a tag is a generic label that you can give a number of different people. If I wanted to say that I'm going to collide and react and bounce normally against every person here, I would say collide against human. Regardless of who came in, regardless of gender, they're all human, so therefore I would have a generic type of collision with that. If I wanted to say, well, specifically for this one person, well, now I'm using the very specific name that I've given that game object. So a tag is for generic, a name is for specifics. And the system inside, all of the code that takes place in there is aware of the distinction, which you will learn to manage. This is what we were talking about, get component and the different components that this has. Every single one of these things here, the inspector where it shows the transform, the cube, the box collider, the mesh renderer, and the default material is the material attached to the mesh renderer. It's built in. But if we were to add the generic behavior script, that is an additional component. Thing to keep track of here is that every single one of those elements is a component of the game object. It's like describing a person by the features that their body has. You have a set of eyes, well, that's a component. You have for the senses, every single one of the senses, tongue, ears, nose, skin, etc. Those are components that we feature. We have a heart, that's a component. We have a brain, that's a component. Every game object is a series of components that are strung together. Every game object at its root has name, tag, and all that, and every game object on the scene has a transform. If you delete the transform, it's weird, but I think you can do that. Don't quote me on that, and I wouldn't even try it. That being said, the components can be created, instantiated in memory, and can be manipulated and accessed. So the secret here is to treat every game object that has a generic behavior script as possessing a component that I can access its contents. So all I need to have forever is a reference or a pointer or a connection to another game object, and I can get that game object's components. It's almost like if I were to ask you, how much is in your wallet? The wallet is a component that you have. How much money is in your wallet? I didn't know that was going to be funny.
Number one, what's in your wallet?
Oh my God, you just ruined the recording. Thank you very much for... We are not sponsors of any credit card system. Please, for posterity. So if I were to ask you how much is in your wallet, I would first have to ask you. I'd have to know who you are. And then I would have to know that you have a component called wallet. If
a mugger that goes up
If you don't have the wallet, yeah, it's a fail, right? The system's going to go, I have no wallet to speak of, so go away.
You lose.
Yeah.
Just go, like,
So, rigid bodies. This is where we are going to learn about how parenting, and this is a secret, not a secret, but it's, you really have to manage this very well. We already talked about the colliders, which is up in the couple slides ago. The collider gives the Unity physics engine the information of its collision, of its volume, of its size. That's what it uses to collide with. Anything that falls outside of the space or the volume or the area, if it's 2D, of the collider, will not be understood by the physics engine. It just doesn't care about it at all. That's where you have things ghost, clip, or phase through one another because it's simply not a part of it. You can also have the collider be larger than the mesh that it's drawing, and then it'll collide before it gets to quote unquote touching that mesh. The rigid body, when you add it as a component to a game object, it tells us physics engine, by the way, we're live, we're working. This is in effect. Physics are in effect for this object. And the rigid body will tell the game engine, instead of using triggers as the main collision geometry, now you're going to use collision. And collision gives you a number of features that a collider just colliding as trigger doesn't give you. For instance, it gives you the resulting speed of these objects' collision, the elasticity of that collision. It gives you the angle of incidence and reflection. It gives you the amount of time that the collision took place before it bounced off. It can also calculate the friction that it has, or how a material, a physics material, will dampen or multiply that collision. These are good things to have, especially if your game is very kinesthetic. It lets you use gravity, as in a global aspect of gravity, where the gravity vector is going to. This is not gravity as in mass and mass as it warps time and space. That is not the type of gravity that we're talking about. We're talking about a general vector of force that is pushing an object towards a direction. Why is this different? Because if you really were to have a sphere of mass 100 and another sphere of mass 1 that are separate, and that was calculating gravity in the real physical sense, you would have the smaller sphere attract, no matter which direction in space it is, towards the larger sphere. And that's not how we're doing this. In this case, gravity for the rigid body means a global vector that you can set on its physics space, physics tab, physics editor, so that it can fake that negative 9.8 meters per square second, second squared. So that's how the rigid body solves that. That it's kinematic. Kinematic means that it still calculates it, but it lets things phase through one another. So if you set a physics object or a game object to kinematic, it'll let things phase through one another, but still give you the collision reactions. Not the reactions per se, but the fact that collision did occur.
For some reason, whenever I was working with it, it just stopped whatever motion the object had.
Because it isn't using the forces. It stops using the forces. You can still have something else collide with it,
Okay.
but it That other object may not be kinematic, but yours might. That means it stops the forces. The interpolate and collision detection, those are those we will not be playing with, but that's about the granularity of that simulation and the constraints. These constraints are going to be really useful for you because it's an easy way for the physics environment to say, I want to keep it 2D in 2D instead of 3D. So any bouncing that happens, ignore that it goes into or out of the screen. Keep it on the screen space. You can say, don't let it rotate. There are certain characters or certain objects that you don't want to rotate. If you have, for instance, in Tetris, you want any one of the cubes to rotate about the Z, right? Rotate basically as if you had a Cartesian system, like orthogonally. You don't want it to rotate away from you. You want it to rotate around like a clock, clockwise or counterclockwise, right? So that's the type of collision that you want, of constraint that you have on rotations. If you were doing a game that, like Marble Madness, well, that ball will be rotating in every single axis. That's fine. It can be hit and spin like a top. It can accelerate on place like Sonic, or it can rotate in every single position, in every single yaw, pitch, and roll. But freezing any one of those, Unity says, I know that you're going to be moving it, you're going to be colliding with things. I'm going to tell it, don't. A rigid body, in a way, it's the last stop for that game object's manipulation in 3D space. That's where it is. All those little elements and variables can be manipulated via script. And some of our game engine events allow you to do that. For instance, we can toggle gravity on and off. Input, we've seen on the key presses, there's two different major types of input, which is in real time and in Boolean form. Real time, it's the key or the event is being triggered constantly. A Boolean type of event is you press the button, okay, I got you. You got it, but I'm not going to call it again until you let go and press it again. That's the difference between turning on a light switch, or constantly feeding electricity to that light switch so that the light goes on. There's a Boolean nature to input and a real-time nature to input. So the screen interface and all the menu buttons and text information that you have probably used in previous classes, those we're not really going to discuss too much this month. The object here is to focus on the events and the things that you do, not necessarily on the information layer. Though that information layer, you will be provided some way of showing information, as that's a useful thing. But you are encouraged to look into the Canvas system. You've probably already used it for menus and clicking and things in and out. So if you have any questions, of course, we'll discuss those. And the thing that I want you to keep in mind with this class, as I said from the previous one, is the exploration of things. This is where all these things you've already done, in a way. You've done, if you're doing your scene, you've done child objects. You will have collision just by adding the rigid body. And by the end of today's lab, you will have a little scene that plays. I've given you that on the demo events package. I want you to play and grab all those, move them around. You can copy component, paste component as you explore this environment. So I'll keep that at short here, and I'm going to stop this recording.